Welcome. Today we're going to be covering the question, what is the integral of sine 2x multiplied by sine 3x? One of the first things that we need to note is the fact that this can be written as sine 3 of x multiplied by sine 2 of x. The order is particularly important because if we are to use this method, which shows addition and subtraction of trig functions, then the positioning of our a and b values, which in this case would be a and b values, is extremely important. So let's rewrite it. Gonna rewrite this as sine 3 of x multiplied by sine 2 of x dx. Now the first thing that we need to note is, where else do we see a sine multiplied by another sine using this method? Well, we see sine A multiplied by sine 3 from arrow 3, and we see sine A multiplied by sine B in arrow 4. So we're going to use these methods. Let's get started. Considering the fact that we see cos A plus B, and we know that we've rewritten sine 3x to be our A value and sine 2x to be our B value, then let's rewrite that in that way. We're going to say cos 3x plus 2x is going to give us cos 3x and we're going to go ahead and use method 3 and 4. So we're also going to go ahead and do method 4 as well. Basically, what we're trying to do is we're trying to manipulate the cosine functions to make sine 3 of x and sine 2 of x, which is the original question, the subject of the formula. Since we know that cos 3 of x plus 2 of x is going to give us cos 5 of x, and we know that cos 3 of x minus 2 of x is going to give us cos of x, then if we were to write it like this, say for instance we write it in this way, cos 5 of x, let's just say that this would be number 1, is equal to cos 3 of x cos 2 of x minus sine 3 of x sine 2 of x. What we can do is now try and add both of these terms, right? So we're going to add 1 and 2. And if we add 1 and 2, we're going to get cos 5 of x, right? If we're adding 1 and 2, you're going to get cos 5 of x plus cos of x. And then you're going to get 2 cos 3 of x cos 2 of x. And these, the sine x's are going to cancel each other out. Now that we know that cos 5 of x plus cos of x is going to be equal to, right? So we can substitute, or rather, we can say cos 5 of x plus cos of x divided by 2 is going to give us cos 3 of x, cos 2 of x. And we can substitute this, which would be this, into any one. We can substitute it into 1 or into 2. Since we are trying to make sine 3 of x multiplied by sine 2 of x the subject of the formula, I'm going to substitute it into number 2 just because it would make everything way more easier. But even if you were to substitute it into 1, it would still be okay. This is going to give us, right, using number 2, right, to substitute. Cos of x is equal to cos 5x plus cos of x divided by 2 plus sine 3 of x multiplied by sine 2 of x. And we know that the original question is, what is the integral of sine 3 of x multiplied by sine 2 of x? And we have sine 3 of x multiplied by sine 2 of x. So we're basically trying to rewrite sine 3 of x and sine 2 of x in terms of this method. So now we know that we can make it the subject of the formula saying sine 3 of x multiplied by sine 2 of x is going to be equal to minus cos 5 of x plus cos of x divided by 2. And we can cross multiply it because we see that this is a fraction. We can also cross multiply because we want to now make it everything under the denominator of 2. So then we're going to get 2. It will give us 2 multiplied by cos of x, so that would give us 2 cos of x. 1 times this whole term, which is just going to be cos 5 of x plus cos of x. We can break this down and say this is going to give us 2 cos of x minus cos 5 of x minus cos of x by 2. And what's 2 minus 1? Well, 2 minus 1 would be 1. So that would be cos of x minus cos 5 of x divided by 2. So that means that another way of writing sine 3 of x multiplied by sine 2 of x would be this. This is another way of writing this. And since we know that, then we can rewrite the integral to say the integral of sine 3 of x multiplied by sine 2 of x is also the same as saying the integral of cos of x minus cos 5 of x divided by 2. And we can also write this down as saying half of cos of x minus cos 5 of x. So let's rewrite that. And that's perfect because then we can take out the half and we can say that would give us the integral of cos of x minus cos of 5x dx, which would then give us the integral of cos x dx, since we're distributing the dx, minus the integral of cos 5 of x dx, so that we can be able to get half. And now what's the integral of cos? Well, that would be sine of x, minus the integral of cos 5 of x would be 1 over 5 sine 5 of x. And never forget your c. And that's the final answer.